Okay. Hi all. Welcome to this video where we're going to continue to talk about quantity discounts in inventory management. And in this video, we're going to be talking about marginal unit quantity discount. In a previous video, we looked at what happens the case where you get quantity discount for all the units that you order. As opposed to that, in this case, we're going to talk about a case. In this case, you get quantity discounts just for the marginal set of units. What does that mean? Here is the example that we used. So if the order quantity is between 0 and 4,999, the unit price will be $3. If the order quantity is between 5,000 and 9,999, it's $296, 10,000 or more, $292. So when you have instead of all unit quantity discount, if you have marginal quantity discount, what that means is that, let's say that your order quantity is 7,000 units. Then for the first 5,000 units, you pay $3 in price. And for the remaining 2,000 units, from 5,000 to 7,000, the remaining 2,000 units, the price will be $2.96. So these are the margins. So these are the ranges in which you actually get the discount. Anything less than that, you don't get a discount, right? As opposed to that, in all unit quantity discount, if the order quantity was 7,000, then for all the 7,000 units, the unit price would be $2.96. Okay. So let's do some calculations. So the first thing that we'll have to do is we'll have to calculate something called the marginal cost, which tells you if you order just enough to reach a particular threshold, what is the actual cost of ordering those QI units, right? So QI is the lower value of the threshold. So if I just order Q1 units, what is the price that I actually have to pay, right? So if I'm just ordering Q1 units, the price that I have to pay is C0 times the difference between Q1 minus 0 units. But if I'm ordering Q2 units, then whatever the cost was before to that, I'm going to add the difference between Q2 and Q1, this range of numbers, times the price within this range of numbers, and so on. We're going to keep doing that, and that's basically what this formula is, right? So once we have that, we can then write our usual formulas for ordering cost, holding cost, material cost, and total cost based upon the fact that if I order some number of units, let's say somewhere in between, let's say capital Q is somewhere here, then the price that I pay, that I'm actually paying for each unit is, well, I know the value of V, so we'll have V0, V1, and V2. So I know the value of V2, and we're going to add extra to the value of V2 based upon what the value of Q is. And that's basically what that is. So to the value of V, we're going to add the extra. So Q minus QI times CI. So that will be the material cost of each particular order. So with that, we have the usual things, and then we'll calculate the total annual cost, and then we'll look at the different options that we have and evaluate the options, right? So let's actually do this example. So let's actually use the data that we had here and go through this particular example and see how things work out. So the first thing that we need to calculate is the value of V sub I, right? So you calculate the value of VI. The first value of VI will always be 0. You'll always begin at 0. Next, we are going to do the next value of VI is going to be, sorry, let me just keep the formula. So the next value of VI is going to be $3. So what does it mean? So what does calculating VI here mean? So here we are saying that if I order if I order 0 items, essentially I'm going to pay $0. That is what V0 essentially represents. So VI, we're calculating V0. Now V1, the value, what we're calculating for V1 here is, what if I order exactly 5,000 units, right? So if I order exactly 5,000 units, then for the first 4,999 units, I am going to pay $3. And for the last one unit, I'm going to pay $2.96. But just we can do, because it's only one unit and there are a large number of units, we can sort of hand wave it a little and say that it's going to be $3 times 5,000. Technically, this should be 4,999 and not 5,000, but That is okay. So that's fine. So it doesn't make a lot of difference. So VI is 15,000. Let me, I don't want the decimal places. Next, this VI is going to be, so we have the $15,000, right? So it's going to be 3 times 5,000 plus, so the 15,000 that we had plus the $2.96 times the difference between 10,000 and 15,000. You know what? Let me the same 5,000 here. Let me just use that. Here I'm going to say again 3 times 5,000 plus 296 times 10,000 minus 5,000. Yeah. That gives me a value of V2, which is 29,800. Now, once I have the value of V1 and V2, I can now calculate the value of Q star. I'm just going to say Q. Or order quant. Yeah, let's say Q star for the time being. So again, we'll use the EOQ formula for this. So it will be square root of 2 times capital D, which is going to be the same for everything, times S again, which is going to be the same for everything, right? Now this is not just going to be S by itself. It's going to be S plus VI, right? Minus divided by H times C. Now that's basically 0, right? I mean, the lower limit is 0, so it's not gonna make that much of a difference. 6324. So again, I'm gonna round this. Don't forget to round it. 6325, right? Did I? Yeah, that should be an absolute reference. C0. Yeah. So with this, I should be able to copy the formulas down and get the right numbers. Yeah. There you go. Again, I don't want to decimal places. All right. So that's my values of Q star, right? Using the formulas that we have here, we have the value of Q star. Now what do we do? So the next step is we have to adjust these values of Q star. Which are the values that we're going to keep? So we can say adjusted. Okay, so what are the rules here? So in marginal quantity discount, if the value of Q is between Qi and Qi plus 1, then we'll set Q star is equal to Qi. If Qi is less than the lower limit in the range, then we'll make it the lower limit. If it is more than the upper limit in the range, we'll just make it the upper limit. So this time it's going to be that way. So 6,325 is more than the upper limit in the range. So we're going to adjust that. So technically it adjusted to 4,999, but I'm just going to make my numbers easier. I'm going to make that 5,000, but this will actually be 4,999. You know what? Just keep it at 4,999. Next, 11,028 again is more than 9,999, right? So it's more than the upper limit in the range. So I'm going to make that 9,999. And finally, 16,961 is the same, is more than 10,000, so it is within the range, so we're going to keep 60,961. So again, 6,325 is more than 4,999. It's more than the upper limit in the range, so we can adjust it to the upper limit in the range. Next, 11,028 again is more than the upper limit in the range, so we can adjust it to the upper limit in the range. And finally, 16,961 lies within the range, so we're going to keep it as it is. Now, if there was another range where it went from 10,000 to say 20,000 or something, then in that case, again, we'll keep the number. But if it's more than the upper limit in the range, we'll take the upper limit. If it's less than the lower limit in the range, we will take the lower limit. But that's not the case here. So we calculate the values of adjusted Q star. And once we have that, we can now calculate the total cost values. Now, the total cost values, the formulas are pretty involved. So we have the ordering cost, the holding cost, and the material cost, essentially. So those are the numbers that we have to calculate. But like I said, so the formulas are a little bit involved. So let's go through the formulas. Let's calculate ordering cost and holding cost first. Annual ordering cost, and annual and material cost, and of course total cost. Okay, a couple of things. Let me make this slightly smaller so everything fits in the range that I'm looking at. Yeah, there you go. Right. Make it even smaller, I guess. And that should be good enough. Okay, so first let's calculate the annual holding cost. So the annual holding cost, usually we do Q over 2 times H times C, right? So but that formula will be slightly modified here, which will be VI. So we're going to say VI plus Q minus Q0, right? Times C0, that's $3 right there, right? So this whole thing so times H divided by 2, right? So it's Q times H times C. So this everything is within here. C times H. Yeah, right. So that's the this is the holding cost. So let me put that there, right? So this is, make sure I got the right numbers. No, I guess I can only check overall values. Let's calculate the annual ordering cost. So this is going to be D over Q times S and finally the material cost. So this is going to be slightly more involved again. So we'll do D over Q again. So these formulas are slightly, oops, I'm sorry. There you go. These formulas are slightly different from what you know before, but we can discuss that in 1 second. D over Q. D should be an absolute reference. Right. Actually, let me make sure I. All right. So D over Q times same thing that we calculated, so it'll be V0 plus Q0 times C0. Okay, got that right. So we got the material cost values. Again, these formulas are pretty involved, as you can see right here. They're pretty involved, so took me a while to input them all, but then there you go. So total cost, you'll notice that this is the cheapest option here, but this is might not always be the cheapest option. You'll notice that the difference between this one is only about $1,300 or something. So it's not that much different, given that the material costs are in hundreds of thousands of dollars. That's basically less than about a percent, less than a percent in difference, right? So that's not that much of a difference. So something to keep in mind. Okay. So here the optimal total cost is that. So definitely the optimal order quantity is 16,961, right? So just like here, so we can calculate these are the three big numbers that we need to calculate, right? 16,961. The cycle inventory is half of that. Then the number of orders is 120,000 divided by 16,961, which is about 7.07 times in a year. Let me do that. 7.08 times in a year. So that's it. So that's the marginal order quantity. So this is about $360,000, and if you do full quantity discounts, you get $354. Which is about $6,000 in difference, which is pretty decent. That's a pretty decent change in price, but that's something to keep in mind, right? So I'm going to end this video here. So this video was about how you calculate the optimal order quantity when you are getting marginal discounts. That's what we have here. In future videos, we're going to see why do suppliers give out quantity discounts? How does it make sense for them if their customers buy larger quantities from them, right? So let's talk about that in the next video. Right? I'm going to stop this video right here. Take care.